Okay, so today's video is on the area of regular polygons. This is topic 2 of our Unit 11 surface area and volume. So a couple things to start off the notes part. We're talking about area of regular polygons. So regular, remember, means that the polygon has all of the same side lengths. So all the lengths on the polygons that we're going to be finding the area of are the exact same. It also has all of the same angle measures, so all the degrees of these corner angles on the polygon are the same. So again, regular means all congruent sides, all congruent angles. Okay, and the distance from the center of a polygon to any side is called the apothem. Okay, I'm not really sure I use that word, but it's the segment connecting the center of the polygon to a side, the middle of the side. So this whole thing would be the side, the middle of the side to the center. That is the apothem. So I'll abbreviate that. Well, I'll just leave it. The radius of the polygon is the distance is the segment connecting the center to the corner or the vertex of the polygon. So anything that connects from the center to a vertex is a radius. Any of these segments that I'm outlining here would be a radius. And then, so what we're going to use for the formula for the area of the regular polygon, we're not going to use the formula that they give you. They don't, if you look it up online, there's a formula that they teach. That formula isn't given to you on the FSA for Florida. So if you memorize it, then you can use it. If not, then the easier way to do it is you already know the area of a triangle formula, so you would just do the area of one triangle and multiply that by the number of triangles you can make that are that size in this figure. So I've kind of drawn a little bit of this figure, a little bit scaled bigger. So and this one has a little bit more sides. This one only has 6 sides, but the area of process to find this area of a regular polygon with 8 sides, an octagon, is the same. So if we look at this octagon, and it's an octagon because, again, it's an octagon because of the number of sides it has. So 8 sides is how many segments there are. If I draw a triangle that has an apothem in it, so this side would be the apothem. It also has half of a side of the triangle, so the half side, and then a radius. That is triangle 1 from in here. And so here, that's that triangle, made it a little bit larger. If I can find the area of that triangle, then I can multiply that by, and each side I can make 2 of those. Mine doesn't look equal here, but if I had drawn my line straight, it would look equal. So this size triangle, there's 2 per side. So this is really a blown up triangle, but of this little skinny one. So per side I can make 2 triangles, so that means that the number of total triangles that you can make that are the size of the area, the one that you found, is equal to 2 times the number of sides. So n is the number of sides. Okay, so if the figure has 8 sides, then that means you can make 2 times 8 triangles, or 16 of this size triangle. Okay. When we're doing this, it's going to become really important for us to be able to figure out, they're only going to give us typically one of these 3 sides. So we're going to need to figure out the central angle, or this other angle, but the easier one to get is the central angle. So the angle is x in this picture. I'll just label x. To figure out the degrees of that, we would use the point from here connecting all the way back around the circle would be 360 degrees. If I'm dividing that into 16 triangles, then 360 divided by 16 will tell me how much the degree is for just this angle. So to figure out what x is for any triangle that you draw, you're going to take the whole degrees for the circle and divide it by the number of triangles that you're going to make that are that size, which is 2 times the number of sides there are. Okay, so the number of triangles is always 2n, so we're going to divide it by 2n. Making sure that when you do this, 2n is essentially in parentheses, so you have to do that first. You have to multiply the number of sides by 2 first, and then divide that. 360 divided by that number. Okay, so if we can get x here, then we can use the trig, if we're only given one of the sides, to figure out any unknown sides. So we'll start doing some examples. The first example isn't going to involve any trig. It's just going to be straight up figuring out the area of one little triangle and multiplying it. But just to get to the hang of that, we're just going to start off simple, and then we'll get into some trig ones after that. All right, so for the first example, if I go ahead and cut this here, I always want to make a triangle that is has the three sides on it as the apothem is one side, so that's the 7. Half of the side is one side of the triangle. We don't know that length. And then the other side is the radius, so this segment here. Okay, they tell us that the side is 24.2, which means this side is 24.2, and the bottom side is 24.2 because all of these are regular. Remember, all three sides, or all the sides on the figure, are the same. So if this is a regular figure, and this whole length was 24.2, then the half side, half of that would be 12.1. Okay, so each of these segments are equal. All right, and then from our previous day's work, we can figure out the area of this triangle by doing 1/2 base times height. And that will give me the area of this triangle. And then this triangle, the base is 12.1, and the height is 7. So the area of just one triangle is 0.5 times 12.1 times 7. So the area of one triangle is 42.35 feet. And then we can always make the number of this size triangle that we can make in this figure is 2 times the number of sides, because I can make 1 here, 2 here, 3 here, 4 here, 5, and 6. So I can make 6 of these size triangles. So my area, I'm going to multiply it by the number of triangles I can make, which in this case is 6. So my area for the whole figure would be 254.1 feet squared. Okay, so try number 2, see if you can get it, modeling this process that we did here. And then you can play the video. I'm going to go ahead and start it. So if I'm trying to draw a triangle, I need always to have the apothem, half of a side, and a radius in. So I'm going to draw it down here actually. So the apothem connects the side to the middle here, so this is also 16 because it's connecting the middle of a side to the center, so the middle of the side of the center is 16. And then I'm going to use the radius here. Alright, so this is the triangle that I'm going to be finding the area of, and then I'm going to multiply that by the number of triangles there are. Okay, so if I pull this triangle out, I have a 16 is my height, and then this side was 13.3, so 13.3 divided by 2 is going to give me, this half side is 6.65, because remember this side is congruent to this. This segment here is congruent to this segment. Okay, so now I have the base and the height, so I have enough to find the area of the triangle. So the area of the polygon is going to be 1/2 base times height, which is the area of just the triangular piece, times by the number of triangles I can make, which is 2n. Okay, it's always 2 times the number of sides there are. So in this case, the base is 6.65, the height is 16, and 2 times the number of sides is there are 1, 2, 3, 4, 5, 6, 7, 8 sides. So 2 times 8. Okay, so that's what I'd be plugging into my calculator. 0.5 times 6.65 times 16 times 2 times 8 equals. So this area would be 851.2, and it was in centimeters, so centimeters squared. Okay, so again we're finding the area of the shaded piece, and then multiplying that by the number of triangles I can fit that are this size in my figure, which happens to be the same number as this, so it's not always 16. Okay, but because there are 8 sides and I can make 2 per side, that's why I used 16. Alright, so those are the only two examples that don't require any trig because they give you both the half side length and the height of the triangle or the apothem. All the rest of them, they're going to only give you one side or part of the side of the pulled out triangle, so you're going to need to figure out the other two sides. So I'll do number 3. I already have an apothem here, so I'm going to use a half side here and then this radius. So my triangle is going to be upside down now, and that's okay. I'm still always finding this angle. So the x angle is always the angle between the radius and the apothem. That's the angle that we're looking for by doing 360 divided by 2n. Okay, so that means there's 360 degrees around this full circle, but I can make 2 of the number of sides there are, because I can make 2 of these triangles per side. So 2, 4, 6, 8, 10, 12. So I'd be dividing by 12, or 2 times 6. That's how I got the 12. Okay, so there's 6 sides, but I can make 2 triangles per side. So 360 divided by, and again I want to do 360 divided by 2 divided by 6, or 360 divided by 12. If you do 360 divided by 2 times 6, then the calculator thinks you're doing 360 divided by 2, but then the 6 is back up here. So you want to divide both of these. So you're doing 360 divided by 2 and divided by 6 to get the degrees 30. Okay, so that's 30 degrees. This was 5. And in order to get the area of this triangle, we need the base and the height, which are just the 2 sides perpendicular to each other. So you already have one of those dimensions, we just need to figure out the other one. Okay, so to do that, I'll give it a variable letter. I already used x in here, so I'll just use y, just any letter in the alphabet that we haven't used yet. So from the 30 degrees, this is when my trig comes in, so this is from unit, whatever unit it was, 7. Okay, on your formula sheet for the geometry FSA, you have your trig formulas. So if you're looking from the 30 degrees, we have to figure out which side of the y is and which side the 5 is. So 30 degrees is opposite of y, so that's the opposite side. It's across from y, so that's the O side. 30 degrees is next to 5, but it's not the hypotenuse. So the hypotenuse is always the longest side. It's across from the 90. So this would be the other of the 3 side lengths, which is the adjacent side. So the trig formula that uses O, opposite and adjacent, would be tan. So we're going to do tan of the angle. So tan 30 equals, and then the tangent equation, we're using this exact equation. We plugged in 30 for the degree. Whatever falls on the opposite side goes over whatever falls on the adjacent side. So this is going to be y over 5. Okay, and that's my whole equation. Alright, to get y solved for, I need to move the 5, so multiplying it, because right now it's divided. So I do the opposite operation and multiply it, so it cancels on this side, so I'm just left with y equals. And then I'm going to do 5 times 30 tan for this calculator, and it gives me 2.89. Make sure your calculator's in degree mode, because we're using degrees. So y is approximately 2.89. I'm not going to clear that, I'm just going to store that in spot 1. So remember, the store function is STO. This means we're going to store a number. The calculator is going to remember it. So store this in spot 1. That way it's exact. Okay. So the M means memory 1, so it's memorizing something in spot 1. All right. So then my area is going to be equal to 1/2 base times height. That's the area of this triangle. And then I have to times that by the number of triangles there are, which is 2n. In this case, there's 16, 2, 4, 6, 8, 10, 12. No, 12 triangles in the figure. Okay, so 1/2 the base was y, so 2.89, but I'm rounding it here, but I'm going to use the exact number in my calculator. 5 is the height, and then there were 6 times 2, so 12 triangles is how many triangles I can make. So this is, again, the number of triangles that you can make that are this size. So I can make 2 per side, 1, 2, 3, 4, 5, 6, 7, 8, sorry, I'm so sloppy with this. 9, 10, 11, 12. Okay. So that's where we're getting the 12 from. And then we're just going to multiply that. So 0.5 times, and then I'm going to recall what was in spot 1. So that was that memorized number. Okay, then times 5 and times 12. So 86.60 would be the area, meters squared. Okay. All right, then for 4, same thing. 46 are similar to this one. They give you the apothem each time, so you're really doing the same process. I'm just going to do one more of those, so I'll do number 6. If you understand that process, you can try those and then just fast forward. Okay, so we need a triangle with the apothem, which is the 6, the half side, and the radius. So we are going to, I'm going to zoom in on this. Okay, so 6 is my apothem, and I don't know the base, so I need to figure out the angle here. And I'm going to do 360 divided by 2n to get the angle. And that's, again, 360 is the whole thing divided by 2 times the number of sides, because I can make 2 of this size triangle per side. So I'm really dividing this into 16 triangles, so that's why I'm dividing 360 by 2 times 8, or 360 divided by 16 to get me my degree. So 22.5. Okay, so that's the angle here. And I need this side for area because I need to do 1/2 base and height of the perpendicular sides to each other. So to do that, I'm going to use trig again. So from the angle, reference angle, I have the side opposite and something on the adjacent side. So I'm going to be using tan again, but my angle changed to 22.5 this time. And tangent still opposite over adjacent, so I'm still going to put x over 6 and solve for x.
Sure, any of the days works. I get here at like 6:30, 6:45, or 6:30, 6:40 every day. Okay. So, all right. Let's see.
Okay, so then, okay, 6 tan, 22.5. So we're going to do 6 times 22.5 tan equals, so that's about 2.5, but I'm going to leave it exact in my calculator and store that in spot 1. Okay. So it's stored in spot 1. Okay, so that's my base, and now I have the base and the height, so I can do the area of the triangle. So area of the full polygon is going to be the area of the triangle times the number of triangles we can make. I keep switching this up between 2n and the number of triangles so that you understand that the 2n is coming from the fact that each side, which is n stands for sides, there's 2 triangles on it. So we can make, in this case, 16 triangles for this particular problem. So 1/2 the base, we just found it to be about 2.48. The height of the triangle is 6, and the number of triangles this can make is 16. So 0.5 times, recall what was in spot 1, that was the trig number we got, times 6 and times 16 is going to give me 119.29 kilometers squared. Okay, so that's how you do the ones on the front. Okay, moving on to the ones on the back. I'm just going to do a couple of these. So 7 through 10 are all the similar type. This paper's so dirty. So 7 through 10 are all similar. Okay, I don't know why. So I'll just do numbers 9. I'll skip to number 9. They're all the same. They give you half of a side, or they give you the side length for each of these. So if we were to create a triangle that has the apothem, a radius, and half of the side, our triangle for this figure would look like this. And the 14 is the full side. So 14 is going from here all the way to here. So our figure is only going to have a 7 here for the shaded triangle that we're doing. Okay, the angle that we're getting is always between the apothem, which is this side, and the radius. So this angle is going to be 360 divided by 2 times the number of sides there are. 1, 2, 3, 4, 5, 6, 7, 8. So 360 divided by 16 is 22.5. I think we had done one. 22.5. Okay, so this is 22, can't see it, so 22.5 degrees. Okay, and we need the base and the height, so we're going to be looking for this side to be able to figure out the area. So this angle from that angle, this is the opposite side, and then this is the hypotenuse because it's across from the 90, and this is our adjacent. So what we want to do is the O and A is again tan, so we use a lot of tangent for the first couple of problems. Tan 22.5, but this time the opposite side, because opposite always goes over adjacent, the opposite side has on it a 7. So we have 7 over x instead of x over 7 like we did on the front. So what we want to do for this one is we want to isolate x, so solve for x. Right now x is in the denominator, so what we need to do is we need to times both sides by x to move it to a numerator. That cancels it on this side. And we're left with x tan 22.5 equals 7. And then we need to get x by itself, so we divide the 22.5 tan out on each side. Okay, so we're going to be doing 7 divided by 22.5 tan, and then that equals 16.9. But I'm going to leave the number stored in my calculator, so I'm going to store this in spot 1. Okay, so if I recall what's in spot 1, there it is. So remember the store button is STO and stored in, you can store it in spot 1, 2, or 3. And then you can recall it from whatever memory it has, 1, 2, or 3. And then to clear store, you just do set it to 0, make sure the calculator is set to 0, and then just hit store, whichever one you want to clear. So if you want to clear spot 1, while it's on 0, you just click store 1. And then it stores a 0, it clears it. Okay, so the base, or the height, or whichever one you want to consider this, is 16.9. So the area of the figure is going to be 1/2 the triangle, or 1/2 base times height for the triangle, times the number of sides, which is the number of sides times 2, which is 16 triangles. So 1/2 the base I will consider to be 16.9. The height is 7, and then 16 is the answer. So I'm going to be doing 0.5 times, recalling what I saved in spot 1 when I stored that number, so it's exact, times 7 and times 16. Okay, so it's 946.37 for my area. Okay, so 7, 8, and 9 are all like that, where you're finding the half side, you're given the half side, so you're finding the length of the other base and then plugging it into the formula. Okay, the bottom 4 are a little different. These are going to give you, if we do number 12 and draw in the apothem, half of the side, and a radius, these are, this time the radius is all given. Okay, so the apothem, the half side, and then the radius is 12.5. That's the side that we're given. So when we draw this triangle out to the side, we have 12.5. And then in order to find the area of the triangle, we need both of these sides. We're not given either one of them this time, so we're going to have to use trig to find them both. So we still get the angle, the central angle, the same way that we have. So it's going to be 360 divided by 2n, where n is the number of sides, so in this case, 6 sides. So 360 divided by, we'll do 12 again, so we already did that to be 30. And then we're going to do, I'll call this side y, this side x. It doesn't matter which one you do first, but in order to get the area of the triangle, you need both of these sides. So this is going to be, let's say, if we do x first. So from 30 degrees, this side is opposite, so this would be x, and this side is the hypotenuse, so h. So looking back at the formula sheet, which trig function would we use for O and H? Okay, it's going to be sine. So we're going to do sine from 30 equals x over 12.5. Okay, and then to get x by itself, we multiply both sides by 12.5, which cancels it here, so the x is going to equal, it's exact, so we can leave it as 6.25. We don't have to store it in our calculator. Okay, now we want to do y. So if I'm looking for y now, I'm going to erase, well, these actually stay the same, the labels stay the same, but y is the adjacent side. And we want to use the 12.5 because we know for sure that that's correct. That was given to us. So you could use the side that you found, but it's better to use the side, just in case you made a mistake on this part, you could still get y right. So we're going to use a and h, which is adjacent hypotenuse cosine. So we're going to do cosine of the angle, which is cosine of the angle is equal to y over 12.5. Okay. So when we multiply both sides by 12.5, we get that y equals, so let's see, 12.5 times 30 cosine equals 10 point. So y is approximately 10.8, but we'll store it in our memory. Okay, so then the area of the triangle is going to be 1/2 base times height times 2n, which is the number of sides, times 2, that's how many triangles you can make in the triangles, in the polygon. So it's going to be 1/2 the base, which is x, was 6.25 exactly. The height was 10.8, and then 2 times the number of sides, there were 6. Okay. So it's going to be 0.5 times 6.25 times, recall what's in spot 1, times 12. So it would be 405.95 square feet. Okay, so for 11 through 14, you're going to have to do trig twice to find both the base and the height of the triangle, so that you can multiply the area of the triangle that you get times the number of triangles that it can make, which is 2 times the number of sides. Okay, and that's the area of regular polygons process.